Hi Year 12. I'm going to do a past paper question today that is, it's in the Unit 9 Lesson 8 folder and it's entitled Rate Constant PPQ. Okay, so that's the one I'm doing. Reasonably straightforward one. I think lessons 7, so lesson 6 is the multiple choice questions, lesson 7 is the first stuff on rates, and I think that one's reasonably straightforward, but do please email me and get in touch if you have any questions on that. Lesson 8, you have got a couple of, well, a few past paper questions, this being the first one, and I'm going to take you through how to do some of those, and I will explain a little bit further about some of the content in that lesson, basically how to determine the initial rate of reaction. Okay, so bear with me, sorry, this is not my slickest video. The reaction between propanone and iodine in the presence of hydrochloric acid was studied at constant temperature. So you should have realised by now that this is the most common example that you will come across when you are doing these rate calculations. And so some of the answers that you learn you'll just kind of be able to regurgitate. However, this is not the only example that you may be given, and obviously you need to be prepared to apply your knowledge. So the following rate equation was deduced. So we can see here that iodine does not feature in our rate equation. And the first question says, suggest why the order with respect to iodine is 0. So I'm going to say iodine does not feature in or before, and that's important, the rate determining step. I've just put RDS for short. I would probably say in the first instance to write out rate determining step in full. Okay, next question. It's only 2 marks and you are given the rate of a reaction. You're given the value for that, you're given some initial concentrations, and you are then asked to calculate the rate constant. So we need to find K and we have to give units for your answer. So you're going to get 1 mark for that and you're going to get 1 mark for that. So to start with, I'm just going to put down the rate equation in its standard, which we're actually given up there. So CH3CO, CH3, that's propanone, and H plus. This obviously comes from the hydrochloric acid. It acts as a catalyst, and therefore the rate is dependent on the concentration of it, because obviously it's a catalyst, it speeds up the rate. So we need to find K, so I'm going to rearrange. So K equals rate over CH3, CO, CH3, H plus, that's a bit sloppy, and then plug in some figures. So we're told that that is the rate, 8.64 times 10 to the minus 7 over 5.82 times 10 to the minus 2 times 4.76 times 10 to the minus 1. And if you do that calculation, you should get 3.12 times 10 to the minus 5. Then you need to work out the units. I've not left myself an awful lot of space here. I'm just going to do that up here. So units, obviously for rate, mole dm to the minus 3, s minus 1. And then down here we've got our concentration units. Cancel, 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 cancel. I'm going to say 1 over this, giving us moles to the minus 1, dm positive 3, don't need to put the positive in, and S1. Okay, so that's the units for that one. This final one, I remember from marking, provided people with quite a few issues, and once you know, it's obvious, which is a silly thing to say, but It's not a difficult question, but it did kind of stump people. But if you get one similar to this again, then hopefully you will pick up those marks. So it said a series of experiments was carried out using concentrations of propanone approximately 100 times the concentrations of iodine and hydrochloric acid. Suggest the rate equation under these conditions. So this question implies that the rate equation is going to be different to what it was. Otherwise, what's the point in the question? So if the propanone concentration is 100 times bigger than everything else, essentially that implies that the rate is not dependent on the concentration of this, because we've just got so much of it. So the rate equation is then going to be just that. So iodine's still not going to feature in it because it doesn't appear in the what's it called, rate determining step or before, and hydrogen ions are still going to appear because they do determine the rate of the equation. Sorry, I'm just in the background trying to find the mark scheme here to see the exact wording. So the explanation point for the second mark says large excess of propanone. So it has CH3CO, CH3 in square brackets to make it clear that it's concentration, or concentration, you could say, of propanone, but it has to, that says propane, whatever. You have to say concentration, basically. You have to imply that. You can't just say propanone. Is effectively constant. And the word constant is underlined, so you have to have said it. Hope that makes sense. Bye.